Hello everyone, I am Asraf A. Ismail and I am the reporter of Module 7 entitled Modern Europe, the Renaissance and Vieta to Descartes. Introduction. We find it convenient to choose the time of the capture of Constantinople by the Turks as the date at which the Middle Ages ended and modern times begun. So, nahanap natin yung tamang um, time ng pag-capture ni Turks sa Constantinople, which is nung Middle Ages, pagkatapos ng Middle Ages, pero nung modern times begun. In 1453, the Turks battered the walls of this celebrated metropolis with cannon and finally captured the city. The Byzantine Empire fell to rise no more. Calamitous as was this event to the east, it acted favorably upon the progress of learning at the west. Objectives. At the end of the topic, the student should be able to discover the 16th century that no mathematician comparable with Vieta, Staple, or Tartaglia. And know that in Vieta's algebra, we discover a partial knowledge of the relations existing between the coefficients and the roots of an equation. So let's move on to the discussion. So the Renaissance, the cultural, intellectual, and artistic movement of the Renaissance, which saw a resurgence of learning based on classical resources, began in Italy around the 14th century and gradually spread across most of Europe over the next 2 centuries. So, ang pagiging cultural at saka intellectual and artistic renaissance, um, I mean, ang pagiging cultural, intellectual, and artistic ng Renaissance ay nakikita na siya sa mga learning base noong 14th century sa Italy at nag-spread pa siya ng sumunod na mga centuries, which is 2 centuries. So, to specify, na-spread pa siya nung um, 15th and 16th centuries sa Europe. So, science and art were still very much interconnected and intermingled at this time, as exemplified by the work of artists and scientists such as Leonardo da Vinci. And it is no surprise that, just as in art, revolutionary work in the fields of philosophy and science was soon taking place. So, dito na time, which is 14th century, yung science at saka art is connected masyado siya sa Renaissance. At saka, um, si Leonardo da Vinci, iniisip na niya to dito na time yung philosophy para matake place. Parang ganun. So, next. The super magic square. It is a tribute to the respect in which mathematics was held in Renaissance Europe that the famed German artist Albrecht Dürer included an order for magic square in his engraving Melancholia 1. In fact, it is so-called super magic square with many more lines of addition symmetry than a regular 4x4 magic square. So dito sa super magic square ay ito yung ginawa ito tribute sa mga tribute siya to respect the mathematics sa Renaissance Europe. So ginawa ito ni Albrecht Dürer. Ginawa ito ni Albrecht Dürer. Pero hindi ito yung ordinaryong square na makikita lang natin na may 4 lines. Hindi yon. Ito yung square na maraming mai-add na shape or lines. Like, how do I say this? Basta hindi siya yung ordinaryong square. Isa itong parang puzzle. Yun. Isa itong puzzle na kailangan natin ma-solve. Like, okay, I will solve it. Ayun, yan yung example. O, di ba hindi siya ordinaryong square? Although mayroon siyang square. So, yung mga yung square na yan, may mga number dyan. Tapos, yung mga shape na nakaloob, yung naka-add na mga shape, yan yung way para makonect-connect mo yung number para makuha mo yung magic number. Ganun. I-add mo lang naman siya para makuha mo yung magic number para ma-solve. Next. An important figure in the late 15th and early 16th century is an Italian Franciscan friar called Luca Pacioli, who published a book on arithmetic, geometry, and bookkeeping at the end of the 15th century, which became quite popular for the mathematical puzzles it contained. So, dito nga, si Luca Pacioli, isa siyang Italian Franciscan, nakapag-publish siya ng librong arithmetic, geometry, at bookkeeping noong 15th century. At ito ay naging popular as a mathematical puzzles. So, itong mga libro na to ay isang mathematical puzzle tapos sumikat siya noong 15th century. It also introduced symbols for plus and minus for the first time in a printed book. So, and symbols that were to become standard notation. So, si Luca Pacioli ay isa din siya sa mga nag-introduce ng mga symbol like plus and minus for the first time sa printed book or makikita natin sa mga libro. So, isa din siya sa mga nag-introduce nun. Next. During the 16th and early 17th century, the equals, multiplication, division, radical, decimal, and inequality symbols were gradually introduced and standardized. So, nung 17th century na, nagsisimula ng 7th century, ang pagmumultiply, equals, division, radical, decimal, and equality symbols ay nakikilala na. And the use of decimal functions and decimal arithmetic is usually attributed to the Flemish mathematician Simon Stevin, the late 16th century, although the decimal point notation was not popular until early in the 17th century. So, yung gamit ng decimal fraction at decimal arithmetic is attributed kay Simon Stevin in the late 16th century, kahit na yung decimal point notation ay hindi pa siya popularized nung 17th century. So, Stephen was ahead of his time in enjoining that all types of numbers, whether fractions, negatives, real numbers, or surds, should be treated equally as numbers in their own right. So, si Stephen ay isa din siya sa mga na-join ng mga symbols at saka real numbers or numbers at nitreat niya ito equally as number in their own right. So, si Stephen ay isa din siya sa mga na-join ng mga symbols at saka numbers. In the Renaissance Italy of the early 16th century, Bologna University in particular was famed for its intense public mathematics competitions. So, sa Renaissance Italy, nung early 16th century, yung university na Bologna University ay sumikat siya dahil sa mga competition nila about mathematics. So, it was in just such a competition that the unlike figure of the young, self-taught Nicola Fontana Tartaglia revealed to the world that formula for solving first one type and later all types of cubic equations, an achievement hitherto considered impossible and which had stumped the best mathematicians of China, India, and the Islamic world. So, si Nicola Fontana Tartaglia ay isa din siya, nag-reveal din siya ng mga ng formula for solving na nagagamit sa Bologna University. So, si Nicola Fontana ay sikat din siya as a best mathematician sa China, India, at saka sa Islamic world. Building on Tartaglia's work, another young Italian, Ludovico Ferrari, soon devised a similar method to solve quartic equations and both solutions were published by Girolamo Cardano. So, sa mga gawa ni Tartaglia, may isa na namang Italian na na-discover na parehas sila na may pagka-similar sila ng method sa pag-solve ng quartic equation ni Tartaglia, which is si Ludovico Ferrari. So, despite a decade-long fight over the publication, Tartaglia, Cardano, and Ferrari, between them, demonstrated the first uses of what are now known as complex numbers, combination of real and imaginary numbers. Okay. So, silang tatlo, si Tartaglia, Cardano, and Ferrari, ay nag-demonstrate sila ng unang gamit kung ano yung kilala ngayon as a complex number, combination of real and imaginary numbers. So, yung imaginary numbers dito is yung pag nagsosolve tayo sa math, like paggagamit tayo ng scientific calculator, so di ba may magsi-syntax error. So, it means hindi syntax error yon, kundi pwede natin sagutin as imaginary numbers. So, Tartaglia went to produce other important. So, si Tartaglia ay nag-produce na naman siya ng importante na formulas at method. Pero, na-ignore lang ito siya. I mean, hindi napansin yung bagong na-produce na other important stuff ni Tartaglia. And Cardano published perhaps the first systematic treatment of probability. Vieta to Descartes. The miraculous powers of modern calculation are due to three inventions: the Arabic notation, decimal fractions, and logarithms. How do I pronounce logarithms? Okay, I apologize for my pronunciation because I don't know how I pronounce it. So, logarithms. The invention of logarithms in the first quarter of the 17th century was admirably timed, for Kepler was then examining planetary orbits and Galileo had just turned the telescope to the stars. So, sa pag-imbento ng logarithm, ang first quarter ng 17th century was admirably timed. So, si Kepler ay nag-exam siya ng about nag-examining siya about planetary orbits at saka naman si Galileo ay nagawa niya ang telescope sa mga stars. And during the Renaissance, German mathematicians had constructed trigonometrical tables of great accuracy, but this greater precision enormously increased the work of the calculator. It is no exaggeration to say that the invention of logarithms, by shortening the labors, doubled the life of the astronomer. So, dito, during the Renaissance German, yung mga mathematician ay nag-construct ng trigonometrical tables of great accuracy, and yun nga, itong time na to, nagagamit na din yung calculator. Okay, next. Logarithms were invented by John Napier, Baron of Merchiston and Scotland, 1550 to 1617. So, naka-invento ng logarithm ay si John Napier. Okay, take note. So, ang nag-invento ng logarithm ay si John Napier sa Baron of Merchiston sa Scotland. It is one of the greatest curiosities of the history of science that Napier constructed logarithms before exponents were used. So, sa history ng science, si Napier ay yung logarithm niya ay nakaka-curious kasi nagagamit na ito before exponents were used. To be sure, Steffel and Stephen made some attempts to denote powers by indices, but this notation was not generally known, not even to Harriot, whose algebra appeared long after Napier's death. The logarithms flow naturally from the exponential symbol was not observed until much later. It was Euler who first considered logarithms as being indices of powers. The most brilliant conquest in algebra during the 16th century had been the solution of cubic and biquadratic equations. All attempts at solving algebraically equations of higher degrees remaining fruitless. A new line of inquiry, the properties of equation and the roots, was gradually opened up. We have seen that Vieta had attained a partial knowledge of the relations between roots and conventions. Piletarius, a Frenchman, had observed as early as 1558 that the root of an equation is a divisor of the last term. So dito na part, nakita dito si Vieta na nag-attain ng partial knowledge sa mga roots and the relation of between roots and coefficients. Tapos, si Piletarius na naman ay isa siyang Frenchman na naka-observe noong 1558 na yung root ng equation ay divisor of the last term. One who extended the theory of equations somewhat further than Vieta was Albert Gerhard. So nag-extend pa ng mga theories about sa equation, maliban kay Vieta, ay meron din si Albert Gerhard, a Flemish mathematician. So, yun nga, si Albert Gerhard ay isang Flemish mathematician. Like Vieta, this ingenious author applied algebra to geometry and was the first who understood the use of negative roots in the solution of geometric problems. So, maliban parehas kay Vieta, si Albert Gerhard ay isa din siyang author na nag-apply ng algebra sa geometry. And isa din siya sa nakaintindi sa paggamit ng negative sa roots isa din siya sa mga nakaintindi kung ano ang gamit ng negative roots sa solution ng geometric problems. He spoke of imaginary quantities, inferred by induction that every equation has as many roots as there are units in the number expressing its degree, and it's shown how to express the sums of their powers in terms of coefficients. Another algebraist of considerable power was the English Thomas Harriot. So, same lang din sila ni Albert Gerhard. Pero English lang si Thomas Harriot. He accompanied the first colony sent out by Sir Walter Raleigh to Virginia. After having, si Albert Gerhard ay naki-accompany sa pinakaunang colony sent out by Walter Raleigh to Virginia. After having surveyed the country, he returned to England. As a mathematician, he was the boast of his country. He brought the theory of equation under one comprehensive point of view by grasping the truth in its full extent, to which Vieta and Gerhard only approximated. That in an equation its simplest form, the coefficient of the second term with its sign change is equal to the sum of the roots. The coefficient of the third is equal to the sum of the products of every two of the roots. So, he was the first to decompose equation into their simple factors. But since he failed to recognize imaginary and even negative roots, he failed also to improve that every equation could be those decomposed. Harriot made some changes in algebraic notation, adopting small letters of the alphabet and letters place of the capital used by Vieta. Harriot's work, analytics praxis, was published in 1631, 10 years after his death. So, yung pinapoint out dito na part is si Harriot. So, siya din yung unang nag-decompose ng equation sa mga simple factors. Pero nabigo siya na i-recognize yung imaginary at saka yung mga negative roots. Saka nabigo siyang i-prove na ang every equation could be those decomposed. So, yun nga, dahil lagi nabigo siya, si Harriot made some changes in algebraic notation. So, nag-change siya and adapting small. So, nung pag-change niya, nag-adapt na lang siya ng mga letters sa alphabet letters. Okay, next. William Oughtred. So, si William Oughtred contributed vastly to the propagation of mathematical knowledge in England by his treatises, which were long used in the universities. So, si William Oughtred ay isa siyang mathematician sa England na nakapag-contribute sa mga universities sa England. And he introduced the symbol of multiplication and as that of proportion. So, I don't know where is the symbol here. Basta naka-introduce siya ng mga symbol of multiplication at saka symbol as a proportion. By him, ratio was expressed by one only dot. In that 18th century, Christian Wolff secured the general adoption of the dot as a symbol of multiplication, and the sign for ratio was thereupon changed to the two dots. Oughtred's ministerial duties left him but little time for the pursuit of mathematics during daytime, and evening his ecumenical wife denied him the use of a light. So, ang buhay dito ni Oughtred ay habang nagpupursue siya sa mathematics, ang buhay dito ni Oughtred sa umaga or daytime ay nag-aaral siya ng mathematics. Tapos sa paggabi na naman ay hindi siya makakapag-aral kasi yung asawa niya ay pinapatay yung ilaw. Kaya hindi siya makakapag-aral sa gabi. So, yun nga. So, si Christian Wolff ay siya din yung isa sa na gawing symbol ng multiplication yung dot, which is yung toldok, which is ginagamit naman natin hanggang ngayon. Algebra was now in a state of sufficient perfection to enable Descartes to take that important step which forms one of the grand epochs in the history of mathematics, the application of algebraic analysis to define the nature and investigate the properties of algebraic curves. Galileo is the founder. Si Descartes ay, I don't know kung Descartes or Descartes, pero na-search ko kasi is Descartes. So, Descartes na lang yun din akin. So, si Descartes, gumagamit din siya ng algebra to state a sufficient perfection. Yun nga. So, Galileo is the founder of the science of dynamics. So, nandito na tayo kay Galileo. So, take note that Galileo is the founder of science of dynamics. Among his contemporaries, it was chiefly the novelties he detected in the sky that made him celebrated. But Lagrange claims that his astronomical discoveries required only a telescope and perseverance. While it took an extraordinary genius to discover laws from phenomena which we see constantly and of which the true explanation escaped all earlier philosophers. The first contributor to the science of mechanics after Galileo was Descartes. So, bago nakapag-contribute si Galileo sa science, ay nauna muna si Descartes. So, si Galileo ay gamit na gamit dito yung mga contemporaries niya. Kasi nga kailangan siya kaya nagagamit yung mga contemporaries. Pero si Lagrange, nag-claim siya na ang kanyang astronomical discoveries ay nagagamit lang siya sa telescope and preference. So, yun lang. So, yun lang yung end ng Module 7. I hope na may naintindihan naman kayo kahit magulo ako mag-explain or something na hindi nyo talaga naintindihan. You can check na lang sa module or I will send this presentation. Kasi nag-present lang ako. Kung hindi nyo naintindihan, kasi nga yun nga sabi nila, pag hindi mo naintindihan, intindihin mo na lang in your own. So, yun lang doon lang nag-end ang aking presentation. So, mag-move na tayo sa Module 8. Yun lang. Thank you.